Hello everyone, welcome to lecture series on computer organization and architecture. We'll discuss lecture number 32 of module number 4. Contents covered in the previous lecture are basic concepts. So under basic concepts, with respect to memory, we have discussed regarding what will be the maximum size of the memory wherein a computer can access. So different types of registers that are involved when a data needs to be transferred between processor and a memory. So the register that we have discussed in the previous class are memory address register and memory data register. So and even we have discussed important points like memory cycle time as well as memory access time, and along with that we have discussed different types of memory like main memory, that is RAM, as well as cache memory and virtual memories. So these concepts was discussed in the previous lecture. Contents covered in this lecture is semiconductor RAM memories. So under semiconductor RAM memories, we are going to discuss how a particular memory can be organized. So how a RAM memory can be organized. Learning outcomes. After this lecture, the students will have a better understanding of semiconductor RAM memories. So here this is the Bloom's taxonomy pyramid. So wherein we are going to understand the organization of a memory. So how it is organized. So hence it is going to fall under the taxonomy level number 2. So now before going to understand the organization of a memory, that is semiconductor RAM memories, so let us discuss the classification of a memory. So there are different types of memories. So first the different types of memories are, so here under memory we have different types. So wherein we have like register, primary memory, cache memory, as well as secondary memory. So all these are the storage devices. So wherein it can store an information like temporary results, data, or permanent results. So even a program or set of instructions. So or intermediate results in the program. So all these are the different types of memories. So it is used for storage purpose. So now when we are going to concentrate on primary memory, here we have two different parts, two different types of primary memory. So one we call it as a read-write memory and another one is read-only memory. So under read-write memory we have two types. So one is called as an random access memory and another one is a sequential access memory. So coming to random access memory, we have further two types. So one is called as an static random access memory and another one is dynamic random access memory. So here we will be concentrating on both the types of memory, that is static random access memory as well as dynamic access random access memory. So when we are concentrating on read-only memories, so we have different types like PROM, EEPROM, EEPROM as well as flash ROM. So coming to secondary storage devices, we have a magnetic disk, we have a CD, direct disk, direct access disk, HD, DVD as well as floppy disk. So these are the different types of memories that are available. So these different types of memories can be used based upon the applications. So now as in this lecture we are concentrating on semiconductor RAM memory. So here RAM, it stands for random access memory. It is made up of using semiconductor technology, so that can be used for storing an information as well as retrieving an information. So that is nothing but reading and writing the data. So it can be done in any order and it is used for such applications like computer or processor memory. So here a memory unit which is called as a random access memory. So it can be, as we discussed, it can be used to store an information or retrieve an information. That is, we can perform a read or write operation. So the read and write operation can be performed in a fixed amount of time. So that is independent of the address, memory address. So it is independent of the location address. So both the operations, that is you go with either read or write operation, ultimately it will be done in a fixed amount of time. So irrespective of the location address. So this is called as an RAM, that is semiconductor RAM memory. So now Semiconductor RAM memories are available in wide range of speeds. So normally their cycle time ranges from 100 nanoseconds to less than 10 nanoseconds. So first when the first introduced, it was introduced in the 1960 year. So they were very much expensive. They were more expensive compared to magnetic core memories. So because of rapid advance in the VLSI, that is very large scale technology, the cost of the semiconductor memory has become less dramatically. So as a result, so now we are using almost semiconductor RAM memories. So now before going with the semiconductor means let us discuss or understand the internal organization of a memory chips. So how this memory chips can be organized. So before going to understand that concept, so we need to decide, we know that in the previous lecture we have discussed, so any given computer or any considered computer can access the memory depending upon the address lines of the computer. So that much number of memory locations can be accessed. So in order to access a memory, so memory will be available in the form of a memory chips. No doubt the size of the memory chip can be anything. Ultimately, the total number of memory locations in that memory chips can be accessed. It depends upon the number of address lines of the computer. So now for example, if we have an memory chip size like 16 into 8, so on the top of the memory chip it will be denoted like 16 into 8. So if it is denoted in has 16 into 8, it is having a particular meaning. So wherein that is 16 into 8, if we perform, the total number of bits that can be stored in that memory device is 128. So 16 into 8 means it becomes 128. So 128 bits will be the total capacity of the memory device. So now here the first part, that is 16, it is going to tell about the information how many number of memory locations can be accessed, the total number of memory locations. So 16 indicates the total number of memory location, and 8, that is the second number, that is 8, this is going to tell about how many number of data bits can be fetched per location. So this is regarding the that is regarding total size of the memory. So the first part is going to give the information regarding the total number of memory location, and second part is going to decide regarding how many number of data bits can be accessed in that particular memory location. So we have one more example like 128 into 8. So 128 into 8 is going to give a 1024 total number of bits, that is you can maximum store 1024 number of bits in that memory device. So wherein the first part is going to specify 128. So 128 indicates the total number of memory locations, and per location you can store 8 bit of data. So hence 128, in every location if I am going to store 8 bits of information, so if I consider total 128 number of memory location, per location storage is 8 bit, so together it comes to 1024 number of bits. So this will be the total size or the capacity of the memory, that many number of bits you can store it in that memory. So if you consider the third example, I have 1k into 1. So here 1k is nothing but k means it is 1000. So 1024 1k into 1 means it is 1024 bits will be the total capacity of the memory device. So among that we have 1024 number of memory location, wherein every location I can access only 1 bit. So that is storage capacity or accessing will be 1 bit. So this is first part is number of memory locations. So second part is total number of data bits I can extract, or total number of bits that is stored in every location. So this is regarding memory organization, that is how the memory chips will be designed. So like this, if you go through with any memory chip, on the top of the memory chip they are going to specify the organization, how it is organized. So this kind of a parameter, if it is denoted, you can come with the conclusion that first parameter is going to give the total number of memory locations, second parameter is going to give the number of data bits can be accessed in that memory chip. So now we know that what is cell. So cell means it is used to store one bit of information. So these cells are organized in the form of an array. So there will be certain number of rows. So every row will be consisting, we call it as an one memory word. So here memory memory is made up of number of cells, so wherein the storage capacity of one cell is one bit of information. So these cells are organized in the form of an array. So we know array means it will be having rows as well as column. So in an array, the row is going to decide the row, in a row any number of bits can be stored. It will be consisting, or it is made up of certain number of cells. So one row is called as one memory word. So all the cells of the row are connected to a common line called as an word line. So all the cells of the rows together, they are connected to a common line that we call it as an word line. So further word line will be connected to an address decoder. So the cells in each column are connected to a sense/write circuit. It is connected by 2-bit lines. So here sense bar write circuits are connected to the data input and output lines of the chip. So now, so this was the things what we are trying to explain. So we have a 16x8 memory chip which is organized in this fashion. So totally we have 16 number of, first parameter says that 16 number of memory location, and second parameter is going to give the information regarding how many number of bits can be stored in every location, or what will be the total number of data bits that can be accessed. So here number of lines are 16, so which is denoted as W0, W1 up to W15. So that is memory cells are organized in the form of an array, one row in one memory word. So all these rows are connected to a common line called as an word line. So now these are the word lines. So in every row there will be a certain number of cells. So here total 16 number of rows are there. Per row I can store 8 bits of information. So these are nothing but they are the cells. So cells will be available. So wherein each cell can be can store one bit of information. And from every cell, that is if you go with a column wise, we have a two lines. Those two lines are connected to a sense/write circuitry. So here sense/write circuit is a circuit wherein it is going to sense the information, that is during loading an information into the cell, as well as in order to read the information from the cell, we are going to make use of sense/write circuit. So and it is having a two direction. So one is you have to store the information into the cell. So can you see the upward direction? So this is going to indicate while store this way direction it is used when we are going to store the information into the cell. And even we can read the we can extract the information from the cell. So we can read the information from the cell. So that is, it is an outward direction. So we can extract, we can read the information. So hence that is it is we have a bidirectional connection to this sense/write circuit. So which is used to store the information as well as it is used to retrieve the information. So with the column wise we have a two lines connected. From every column two lines are connected to this sense/write circuit. So one you can use to store the information and another you can use to retrieve the information. So here if I want to access any particular memory location, so that is every word means if I want to access any memory location among the 16 words, so among 16 rows, I have 16 rows, so that is nothing but 16 number of memory locations. So here if I want to access that particular row or a particular memory location, then I have to access with the help of an address. So therefore we require number of address lines. So here we have an address lines like A0, A1, A2 and A3. So these are the address lines. So why we are concentrating only 4 address lines? Because 2 to the power of 4 becomes equal to 16. So hence we require only 4 address lines in order to access any one of the memory location among the 16 address lines. Why? Because 2 to the power of 4 is equal to 16. And these address lines are connected to the address decoder. So we know what is decoder. So decoder means among the received information. So here we have a 4-bit of information. So among total 16 lines, it is going to select one of the line. So one of the line will be activated. Among 16 lines, one of the line is going to get activated for the received input information. So here received information is 4-bit. So according to the 4-bit received, the decoder is going to activate one of the line among 16 lines. So along with this address information, we have total 8 bits of data lines. So that is B0 to B7. So why? Because if you concentrate on the memory chip organization, we have a memory chip organization as 16 into 8. So therefore we have 8, we need to extract 8 bits of information or store 8 bits of information. So therefore total number of lines, output lines, input or output lines are of 8 bit. And along with that we have an additional input lines called as an R/W bar. So R/W bar control signal can be used in order to perform read or write operation. So along with this control signal we have one more control signal, so that is called as chip select. So chip select is denoted as CS. So here CS is used for chip select. So there will be a multiple number of memory chips. Among those multiple memory chips, we need to activate at a time any one of the memory chip. So this chip select is going to select one of the memory chip among the many number of memory chips. So this, whatever you are going to see this diagram, this kind of memory organization chips can be several number of units may be available. So among such several number of units, this chip select unit is, chip select line is going to select one of the memory chip. So for this reason we are going to make use of chip select. So now here the word lines is connected to the address decoder. The cells in each column are connected to a sense/write circuit by the 2-bit lines. So the sense/write circuits are connected to the data inputs or output lines of the chip. So here output of these are connected to the data input/output lines, and address decoders are connected with these word lines. So now in the figure what we have discussed considering as an example, so it is a very small memory circuit consisting of 18 words. So 16 words, so that is 16 number of memory location, and per location it is of 8 bit. So hence this we are going to refer it as an 16 into 8 organization. The data input and data output of each sense/write circuit are connected to a single bidirectional data line. So that can be connected to the data lines of the computer. So we are going to make use of a bidirectional data lines. So we have seen two-way arrow direction. So this is two bidirectional arrow direction in under every sense/write circuit. Why? Because we can extract the information or we can store the information, read or write the information. So as I told, we have a control signals like R/W bar and chip select. So here as I told, R/W bar, that is read/write bar, input is going to specify the required operation. So that is either read or write operation. So chip select pin or the input, it is used to select a given chip in a multi-chip memory system. So whenever there are multiple chips in a memory, among the multiple chips one of the chip will be selected. So wherein suppose it might be there will be a multiple chips in a memory system wherein each chip is of 16 into 8. So I want to select any one among them. So then we are going to make use of a chip select. The memory circuit which is shown in the figure, it is going to store total 128 bits of information. So thus it is going to almost require 14 external connection. So 14 external connections, it may be with relevant to address, data as well as control lines. So say for example here 4 number of address lines we have used. So external connections are 4. So 4 plus 8, it becomes 12. So 12 plus 2 external control lines R/W bar and CS. So almost it becomes 14. Along with this we require even 2 external power supply, that is for VCC and ground connection. So that is, it also needs 2 lines for power supply and ground connection. So total it might become 16 or at least 14 lines external connections are required. So now let us consider one more example. So we have consider a circuit which is having 1024 number of memory cells. So total number of memory cells are 1024. So whenever we have 1024 number of memory cells, it can be organized in a different way. So one such organization is, I can go with 128 into 8. So 128 into 8 indicates it is 1024. So 128 indicates that many number of memory location, and per location 8-bit storage. So total it comes to 1024 number of memory locations. So wherein it requires total 19 external connections. So if the same 1024 memory cells, even it can be organized as 1k into 1. So that is 1024 number of memory locations, and per location I can store only 1 bit of information. So now these are the different way of organizing the memory. So either you can go with 128 into 8 format, or you can go with 1k into 1 format. So ultimately one indicate, so here in case of 128 into 8 you can extract 8 bits of data at a time, whereas in case of 1k into 1 you can extract only 1 bit at a time. So now let us discuss. So already this kind of a organization we have discussed just now. So now we'll go one more type of organization, that is 1k into 1. So how exactly I can extract only 1 bit of information from the memory among 1024 number of memory locations. So now if I want to go with this organization, then I have to extract 1024 number of memory locations. So if I want to extract 1024 number of memory location, then at least I need 10 bit of address. Why? Because 2 to the power of 10 becomes equal to 1024. So then only one data line is required, because it is 1k into 1 organization or 1k into 1 format. So this total it is going to require 15 external connections. Why? Because 10 bit for address, 1 bit for data, it comes to 11 bit, and 2 bits for R/W bar control signal and chip select, so it becomes 13, and 2 lines external connections for power supply and ground. So total it comes to 15 external connections. So now this is the arrangement of 1k into 1. So now we as we know that, so if I want to access 1k memory number of 1k number of memory locations or 1024 number of memory locations, then I require 10 bit of address. So this is a 10 bit address, and have one data input bar output line. So you can store and retrieve information, hence it is a bidirectional bus. So bidirectional data bus, so it is of 1 bit. Address lines are 10 bit, data line is 1 bit, and we have a control signals like R/W bar and chip select. So now here the organization is done in a little bit different format. So now here among 10 bit address, so it is splitted into 2 bits, it is splitted into 2 parts, so that is 5 bits each. So 5 bits will be concentrating on row address, and another 5 bit will be concentrating on column address. So now among 10 bit address, so it is splitted into 2, 5 bits each. So 5 bits will be for row address, and another 5 bit is for column address. So now if I am having a 5 bit row address, so all these 5 bits are connected to the decoder. So the purpose of the decoder is to select one among the input out of that many number of output lines, it is going to select only one output line. So now we know 2 to the power of 5 means it becomes 32. So hence we have 32 word lines. So here that the 32 word lines are denoted as W0, W1, so on up to W31. So total number of word lines are 32. So why? Because we have 5-bit row address. So 2 to the power of 5 means it comes to 32. So therefore we have 32 word lines. So here each word line, so each row will be having a capacity to store 32 bits of information. Each row will be consisting of 32 number of cells. So we have 32 number of rows, or we have 32 number of memory locations, or we have 32 number of word lines. Every word line or every memory location or every word line is having, or every row will be having a capacity to store 32 bits of information. So 32 number of memory cells will be connected for every word line. So one word line means it will be consisting of 32 number of memory cells. So per word line, if it is 32, then 32 into 32, it becomes equal to 1024. So here row address is of 5 bits. Because of 2 to the power of 5, I may get 32. I will be getting a 32 number of word lines, or 32 number of rows, or 32 number of memory locations. So wherein each word line or each row or each location can store 32 bits of information. So hence number of word lines are 32. So this is 32. Number of word lines are 32, or number of rows are 32, or number of memory locations are 32. So in that every location I can store 32 bits of information, or 32 cells are present. So hence it becomes 32 into 32. The total number of memories cells becomes 1024. So all these are connected to sense/write bar circuitry. So but the objective is to, I cannot no doubt that all the 32 lines, if I select among these 32 word line, any one of the word line will become activated. So when any one of the word line becomes activated, I can extract all the 32 bits from all the 32 cells corresponding to that particular word line. So say for example W1 line becomes active according to the input address given. So whenever a W1 line becomes activated, all the 32 cells in that row becomes activated. So all the 32 bits of information will be available in a sense/write bar circuitry. So all 32 bits can be extracted, but our objective is only one bit of data. Organization is done in the form of 1k into 1. So among 32 bits of information, I need to access only one bit. So now how to get only one bit of information? So it is done by using the remaining 5-bit address. So among total 10-bit address, 5 bits are used for selecting a one of the row. So now remaining 5 bits, it is going to concentrate among the 32 columns. One column bit will be selected. So 5-bit column is address is going to make a decision of selecting among 32 cells. One of the cell is going to get activated. So these 5 bits is going to concentrate on selecting a one bit finally. So hence we are going to make use of one more additional circuit called as 32 to 1 output multiplexer and 32 to 1 input demultiplexer. So you might be knowing what is multiplexer and demultiplexer. So multiplexer is, it is many inputs one output, and demultiplexer is, it is single input and many outputs. So now here whenever we want to read the information, whenever we want to extract the information, we will be using multiplexer. So whenever we want to store the information, we will be using demultiplexer. So now hence the word says output multiplexer and input demultiplexer. If I want to read an information, we will be using multiplexer, hence it is called as an output multiplexer. We know what is multiplexer. Multiplexer means it is many to one. and when I want to store the information I will be having only one bit. So hence demultiplexer means it is one to many. So input demultiplexer, input means I am going to store over there, so hence it is called as an input demultiplexer. So there will be one input and 32 number of outputs. So totally here we will be having 32 number of sense/write circuitry. So here among 32 number of outputs, so when any one of the row is going to get activated, all the columns, 32 columns are going to get enabled. So all the 32 bits of information will be stored in a sense/write bar circuitry. So wherein your 5-bit column address is going to select one of the bit among this. So why? Because again 2 to the power of 5 is 32. So these column address becomes the select input lines for 32 to 1 multiplexer. So wherein among 32 lines it is going to select one of the line. So this acts as a now select inputs for the multiplexer. 32 is the total number of inputs, so 1 will be the output. So similarly again it is going to happen in case of whenever we want to store the information in a particular cell. So again for 1 to 32 demultiplexer, 1 is the input, 32 will be the number of outputs for the whenever we want to store the information. So again 5-bit column address is going to make a decision among 32 which particular bit needs to be selected. So this is regarding organization of a RAM memory when we need to organize 1K into 1 memory. So this is the way of organizing the memory, that is in the form of 1K into 1 format. So here the above figure shows the organization. So totally it requires 10-bit address which is divided into group of 5 bits. So each corresponding for row address as well as column address. So row address is going to select a row of 32 cells, all of which are accessed in parallel, but only one of these cells is connected to the external data line. So that is completely based on the column address. So commercially available memory chips contain a much larger number of memory cells than what we have discussed in the examples. So commercially when we go, there will be the memory chip size will be larger. So large chips essentially have the same organization, but it is going to make use of a large memory cell array and have more number of external connection. So for example, if I go with 1 gigabit memory chip, so it will be having 256 mega number of memory locations, and every location it can store 4 bit of information. So in which case we require a 28-bit address is needed, and 4 bits are going to transfer. 4 bits of data is transferred, that is to or from the memory chip. So this is 1 giga means I can go with this many number of locations. So if I want to go, if I want to access 256 mega number of memory locations, I require at least 28 bits of address lines. And as usual 4 bits means number of bits we are extracting to or from the memory chip. So conclusion is we have discussed organization of semiconductor memories. So that is we have taken 2 examples. One is a 16 into 8 memory, 16 number of memory locations and per location 8-bit, and another one is 1K into 1 format. So how a memory can be accessed in order to store the information or in order to retrieve the information. So these concepts we have discussed in this particular lecture. Thank you.